Hi everyone, welcome to another video. Now here we are introducing the idea of exponential functions. And we've talked about functions quite a bit earlier in this video, or early in this series I should say. And now we're moving on to a couple of new functions that we haven't really seen too much before, starting with the exponential ones. Now all of these exponential functions, we've kind of dealt with exponentials before. We looked at these with exponential equations and indices and things like that, but we want to investigate in this video what a equation like this is going to look like when we actually graph it. Now, doing this on an xy plane, we have our y-axis equals 2 to the power of x here. Now, just to recap some ideas, this guy down here, that's our base. That's our base number, and the thing up here is my power or exponent. Okay, and like for a lot of different graphs that we've looked at, we're going to start off doing this quite simply by just inputting in different values of x and seeing what happens to the y. So let's just start with a table of values, and we're going to move on to really get you guys understanding these exponential functions, how they look like, why they look the way they do. We're going to use a lot of analogies and real world examples because these actually have quite a big carryover effect into the real world. Now, if I draw up my table of values, I'm going to pick a couple of values ranging from -2 up to +2. Oh, let's go all the way up to 3 actually. Okay, so I'm going to substitute in all of these values of x into here. So my first one, I want to find the value of y, and substituting in x, that gives me 2 to the power of -2. Now, when we take negative powers, remember we get the reciprocal and the denominator gets that power, but the sign changes. So 2 to the power of -2 becomes 1 over 2 squared. This is the negative indices relationship that we looked at before. So this guy here is going to be 1 over 2 squared gives me 4. 2 to the power of -1, that's like saying 1 over 2 to the power of 1, which gives me 2. So this is going to be 1 over 2. Inputting in 0. Now 2 to the power of 0, thinking back to indices, anytime we have a power of 0, I get 1. And so on and so forth. Plugging in the 1 here gives me 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. And 2 to the power of 3, which is 8. So if we wanted to graph something like this, I have my y-axis, I have my x-axis. I'm going to put in a couple of values here. So 1, 2, 3, -1, -2. And I have 1, 2, 3, 4, 5, and then all the way up to 8. So plotting these points in, when my x is -2, my y is 1/4. So that's going to be sort of all the way down here, because that gets to about 1/4 here. And when x is -1, that gives me -1/2. So that's going to be about there. Whoops. Why is my thing glitching up? Here we go. When x equals to 0, I get a value of 1 in the y here. When x equals to 1, I get 2. When x equals 2, I get 4. So 1, 2, 3, 4 up here. And then when x is 3, I get 8, which is sort of like all the way up here or something like that. But if we actually sketch this out, we're going to get something that looks like this. And as I keep increasing, my thing is going to just shoot up steeper and steeper and steeper. Because think about it, the next thing is going to be 8, so when x is 3, y is going to be 8, so that's going to be like way up here, we said. And when x is 4, y is going to be 16, so that's even higher. So these exponential graphs, they shoot up quite quickly. Now, we're just going to take a little bit of time to talk about some real-world examples of this, because this is just a gentle introduction into a new type of function here. And we're going to try to talk about what happens sort of like around here. What happens when our graph gets, when our x values get smaller and smaller and smaller, what happens to the y? Now, first of all, let's just confirm this is a function. So remember, our functions are these types of graphs where one x value produces one y value. And we can pretty clearly see that here. This is clearly a function. One x value produces one y value. This one x value produces one y value, and so on and so forth. So this is definitely a function because it obeys this definition that we talked about before. Now, let's just look at a couple of real-world examples here. So a really good way to think about exponential functions is in terms of time. If we let this x-axis be some type of time. Now, a good example of this is how, for example, viruses spread. So one person here is essentially infected. So one person has a virus, and this one person interacts with another person. So for example, we get this one person at time 0, for example. So no time has passed. This is our starting point. So that's our one person here at time 0. Now this one person is going to interact with another person. And now this person becomes infected. So both these people are infected. So as, I don't know, a day passes, for example, this one person infected becomes 2 people. Hence, this guy up here. After 1 day, I have 2 people infected. Or we can look at that here. At 0 days, one person's infected. Say another bit of time passes, that one person becomes 2. Now these 2 people now are going to interact with 2 more people. And when they interact with these people, I get 4 people infected. So at each time t, my people infected are doubling. I've gone from 1 to 2 to 4, and these 4 people, they interact with 4 more people, and I get 8 people infected. And we can keep going along this pattern. After the 8, sorry, they interact with 8 more people. I now have 16 people infected. So this is what an exponential graph can kind of model. Because if we look at the interactions between all of these values, let's say x was the time and y was the people getting infected. We can see a pattern of between each of these little notches, my 1 person became 2. There was a doubling relationship. My 2 people became 4. We doubled. My 4 became 8. My 8 will become 16. My 16 will become 32. And really quickly, you can see there's an exponential relationship. And we say that there's an exponential increase, a really quick increase. And we can model something like infection rates from a virus or something using my actual graph here. Now, that's cool. This hopefully gives us an idea of how this works, but let's look at what happens we've explored this side of the graph. Now let's take a moment to explore this end of the graph and see what's actually happening for smaller values of x. Now, another really good analogy I've heard for this, because the infection thing's good because that's good for the positive, for example, x values, because we have whole people. We can't really have fractions of people here, half and a quarter. So we need another way to visualize what's actually happening here. So we understand this part. We just need to understand everything happening to the left of this 0 here. Now let's go back to this time analogy and this idea of things doubling. Let's say we had a doubling machine. So what we mean by that is, like, I put an item in, which is some particular size, right? So I have my machine, I put in one thing. It's at time 0, it's normal to scale size. And as time passes from this time of 0, it's gonna double and double and double. That's all this stuff happening over here. Now, we want to think about, well, what about before that? What size was it, say, a minute ago? So we're starting at 0, at time 0. Then in theory, and this is just a thought experiment to get you thinking about this, what would its size have been a minute ago? Well, it would have been half the size. And that's where we get this particular number here. So this item, this would have been its size. It would have actually been half. And a minute before that, it would have been half of half, which is a quarter. So this is going to keep getting smaller, smaller and smaller and smaller. This is a quarter. Now, going in this particular direction, we said that everything doubles. But thinking about as we go to the left-hand side, as we go to the right, everything's doubling, everything's great. As we go to the left, as our x values get smaller, my y values here will keep getting divided by 2. So going from example 1 to a half, we're halving this, we're dividing by 2. Going from a half to a quarter, we're dividing by 2. It's getting smaller. So the next step is going to be taking a half of a quarter, or dividing by 2. My thing in the doubling machine once again gets halved. It's getting smaller and smaller here. It's going to become 1/8. So this guy here, at, for example, -3, when x is -3, this becomes 1/8. And you can see this gets smaller and smaller and smaller and smaller. It goes from 1 to half, to a quarter, to an 1/8, to a 16th, to a 32th. It keeps getting smaller and it approaches 0. So it's going to keep this graph. It's going to get smaller and smaller and smaller and smaller and smaller. And it's going to approach this 0, but it's never actually going to become 0. Because our fraction's getting smaller and smaller and smaller as x approaches, for example, -infinity. As we're going these really tiny values of x, our fraction gets really minuscule, tiny, really small, but it never touches 0. So we're actually going to write that here. The graph never touches 0. And we have a special name for this when we have something that approaches but never touches. We call this an asymptote. I'm going to write that word here because it's a bit of a weird word. We have an asymptote So an asymptote is a line the curve approaches but never touches. And that asymptote is going to be the horizontal line of y equals to 0. In other words, the x-axis. Because remember, our y equals something, these are horizontal lines. So for example, y equals 1, y equals 3. These are horizontal lines. Y equals 0 is my x-axis, which my graph is going to get really, really, really close to, but never actually touch. So that brings us to the end of this video, and like I said, it was just a slow, gentle introduction to understanding this curve and understanding, well, this particular graph, this function of y equals 2 to the power of x, this exponential function. And hopefully this gives you a couple of real-world examples and ways to think about how this function looks like and why it actually looks the way it does and what it will look like for really big values of x and really small values of x. And in the next few videos, we will look at some transformations of this function. But that brings us to the end of the video today. Thank you so much for watching, and I will see you in the next one.